Alright, welcome back. Let's finish this by kind of bringing it all together on this final sheet. Find the one that says Super Summary Sheet. I believe it was part of part 3. It's the second sheet of that. Alright, here we go. So we're going to look at these 3 objects. A great little summary here of what we've been talking about. And the first thing we have here is the original size star. Anytime you see an asterisk, it means there's hints at the bottom. But this is a sun-sized star. Or one solar mass, sometimes called. Here we have what we're calling the large stars, and finally the extra large stars. And here's what they become. So the name of this first object overall, notice it says not the core, not the middle, just the whole thing. This is a planetary nebula. This is what our sun is going to become, so it goes down this column. Now the core that's lighting up this planetary nebula is that carbon crushed thing called a white dwarf. And that was the core, and it's been crushed, and now it's called a white dwarf. Remember, it's made of carbon. We'll get to that in a minute. Alright, here, the second thing, this phenomenon, since it's spinning apparently and set up a magnetic field, this is a pulsar overall. This thing at the middle of it, the name of the core, is the neutron star. Third one over here. Here we have our black hole. Thing causing that, the core, the crushed core, is called the singularity. Okay. How big are these cores? Well, they're hints at the bottom once again. The first one, the size of this thing, is about the size of the Earth, which is amazing. It's been crushed that much, a star all the way the size of the Earth. Second one here, it's about 10 miles wide. Classically, people say that it's the size of Manhattan, but a lot of us have never been there and don't know that size very well, but about 10 miles wide. And the third one here, if I were to ask for the size, they say it's infinitely small, whatever that might mean to you. All right. A lot of confusion about that even in the science community, but we'll just say infinitely small. It's so crushed that you couldn't see it like I'm showing it here. You'd never really see it. What is the core made of? What is that core made of? Remember, the last thing that we made was carbon. We meaning our sun. Here, the last thing made here, you remember, was iron. But remember, during the explosion, the core gets crushed and the protons and electrons crush together, making neutrons. So really, the core is made of neutrons more than anything. Here, what is this substance? Because the neutrons were crushed together even more. You know, I will never ask you that. I'm not sure anybody really knows. How long is the lifespan overall for each one? You may recall that our sun is going to last about 10 billion. So will stars about that size. This one here will last several million. Whether it be 16 or 48, but just several million, as opposed to the 1 million-ish of this very short-lived star, the largest of stars. Oh, the irony. They burn their fuel quickly because they're so big. Kind of like a big car burns fuel faster. A rough analogy. Did a supernova occur? Well, for our sun, no, we never will blow up. So when this thing happens, it's kind of a gentle process, relatively speaking, when this planetary formula is made. Planetary nebula formula. And pulsar, yes, it went supernova. And yes, this one went supernova to create a black hole. That's what allowed things to get crushed so dramatically and form these crazy objects. What's a good color when it was first born? Well, our star was yellow, and there are other colors that could be too, but it won't be hotter colors because those go to the bigger stars. So we're going to say that both of these are by hotter colors. Of course, I mean the ones that are blue because they burn so hot. There's lots of matter there to crush and make things very hot. The expanded phase name, that's definitely confusing at first. I'm just saying, what is it called when it gets big? So before this thing happens, remember that it gets big, and we call it a red giant for our sun. The large stars become a red supergiant. Supergiant being one word. And even though they maybe should have their own name, they're still called a red supergiant, these really, really big ones. So what did stop the shrinking? Remember, gravity keeps crushing. What eventually stopped it? You may recall from the notes that electron repulsion stopped ours. So in the middle, as the electrons got close, eventually remember, electrons, negative things, don't like to be near each other. Things that have the same charge, I should say. So they stopped, and it couldn't go any smaller, and so it actually fought gravity. Now with these bigger stars, it just keeps crushing. The electron repulsion is not enough. So this is crushed, remember, to make neutrons. So what stops it? Well, some call it neutron repulsion, but in general, neutrons don't like to be near each other. So we'll just say neutron repulsion. Even though neutrons are not charged by repulsion, I'm just saying they don't want to be near each other. And finally, nothing really stopped this last one. That's why it collapsed to infinity. Okay, thank you very much.